Hi guys, good morning. This is Venkat Muriki. If you remember, the idea behind this kind of sessions is just to ensure, just to give enough confidence to the students about how to master inorganic chemistry. As you guys knows, it is inorganic chemistry is not to be memorized. It's not boring. In fact, it is highly scoring. Because if inorganic chemistry, if you know, you'll know. If you don't know, you'll not know. You don't have to work for that in the exam. So that is the beauty of inorganic chemistry, and most importantly, the amount of time you're going to take to solve all the questions in inorganic chemistry is pretty less. And this saved time can be utilized for other questions as well. So here in the series of inorganic chemistry, like how do we unfold it? You are thinking it, how do we unfold inorganic chemistry? The purpose of Teach Tigers here is, we are here to explain you how to understand, how to analyze inorganic reactions. Because of this, you will definitely develop some kind of interest in inorganic chemistry, just like your physical chemistry, organic chemistry, or physics or mathematics. So our objective here is to develop some kind of interest in inorganic chemistry. It's not boring at all. And therefore, we are coming up with this kind of sessions. And this is the second session we are coming up with inorganic chemistry, the unfolding of inorganic chemistry reactions and concepts. In this process, guys, see here we have a reaction. This boron trioxide with phosphorus pentoxide gives boron phosphate. So again, two things. Do we need to memorize it or do we need to understand? As we discussed in the beginning, we need to really invoke certain basic concepts which you learned in school or 11th class. School and 11th class. Very basic concepts like what? You need to know simple acid-base reactions. You need to know certain redox reactions wherein oxidizing agents, reducing agents we discuss, and of course you need to apply simple mechanism and some logic. And last but not least, some concepts of physical chemistry. So guys, acid-base reactions, redox reactions wherein you came across good number of oxidizing reducing agents, you need to know basic concepts about those compounds and simple mechanism and logic. Apart from that, and the concepts from physical chemistry like thermodynamics, it may be electrochemistry, maybe, or equilibrium, maybe. These are the chapters where we utilize basic concepts and understand these reactions. So guys, now look at this reaction. Boron trioxide with phosphorus pentoxide gives boron phosphate. How do we understand this? Generally, to guess the products, to understand the reactions, what all we need to know? We need to first understand what are the nature of the reactants. What is the nature of the reactants? So when I say nature of the reactants, what does that mean? So the reactants are what? The reactants here can be acid or base, can be oxidizing reducing agents, or it can be simply some precipitation kind of reactions, or non-redox reactions at times. So basically reactions can be different kinds. The reactants can be different kinds. Maybe the reactants can behave themselves as acids and bases, or they can behave something like oxidizing reducing agents, or sometimes simple precipitation reactions may drive the reaction, or sometimes the other factors which will result in so-called non-redox reactions. It can be any of this or sometimes combination of these also. So let us start with reaction 1, boron trioxide with phosphorus pentoxide. So here, the moment you can see, here, this is acidic. This also is acidic. The funny thing here is, at first instance, you may understand, how can two acids react? How come two acids react? Yes, but a reaction is, seen, boron phosphate. So this is a unique reaction where two acids are reacting. But how should an acid react? At first instance, you may think that there is no reaction, but that's wrong. Now these two acids, so generally two acids can react here under the circumstance where out of those two, whichever is stronger one will force the other one to act as a base. I repeat, a key point, when you come across two acids reactions, the stronger one will force the weaker one to act as a base. And that's how a reaction can happen between two acids also. I mean, this is not a common thing, rare, but it is seen. It is seen. So here, guys, now boron trioxide, and here definitely this is aqueous phase. We have water. Now therefore, boron trioxide is simply anhydride of boric acid. We know that. However, phosphorus pentoxide is an anhydride of phosphoric acid, H3PO4. This is H3PO4. P double bond O, OH, OH and OH. Boric acid is BOH, OH and OH. And mind you, definitely any entrance examination or board examination may ask you one question at least on structure, any question related to structures. So this is something phosphoric acid and boric acid. This is how it looks like. Right. Yeah, so what's next? Here, I invoked a very important point saying that two acids are reacting. Out of that, the stronger one will force other one to act as a base, point one. Second point is, I also gave the structures of two compounds. So these are two key things which we discussed. Now, how do we expect the reaction? So we should know which of this is acidic, more acidic, and which of this is less acidic. Obviously, here, if you look at phosphoric acid, this is stronger acid and this is weaker acid. Therefore, this will be forced to act as a base. A base. So naturally we know if this is acting as an acid, the H plus can be lost. Here OH minus should be lost because this is a simple neutralization reaction. This is a simple neutralization reaction. Neutralization reaction. So what do we get now here? Obviously, this is, if you have from this, you end up with PO4 minus 3. And therefore here, we assume it as B plus 3. Not reported. For the sake of reaction, we are considering B plus 3, but B plus 3 is not reported. B plus 3 is very difficult to form. However, to explain the product here, we are taking B plus 3 and phosphate. Obviously, this is simple acid-base reaction and resulting in BPO4 minus, BPO4, sorry. That's how the reaction. So here, what are the key points we have learned? We said, I'll just summarize. So in order to understand any chemical inorganic reaction, we need to first understand or study the reactants. So what are the reactants? Are they acidic? Are they basic? Are they oxidizing reducing agents or simple precipitation reaction or a complex reaction? Any possibility is there. So first we need to understand the nature of the reactants which are reacting. That will give us a fair idea what kind of reaction is going to happen. Here definitely both are acids, but the stronger acid is phosphoric acid, weaker acid is boric acid. That's the point. And that made us to decide that a neutralization reaction should happen and the product is this. That's how we explain this. Right? So question is, Now, likewise, we have many questions. I should say, now every question will have one or the other. See, there are hardly any, maybe 5%, 10% questions in organic chemistry which has to be memorized. Because we say memorized because the products depends much on the experimental conditions. And it is very difficult for us to give some logic or mechanism for that or to understand through concept. Otherwise, 90% reactions can be understood by simple concepts. And moreover, IIT NEET kind of exams are not there to test your memory. They're going to test your basic concepts. Are you aware of this or not? Are you aware what is oxidizing agent? What is reducing agent? Are you aware when is the redox reaction happening? Are you aware when is the nucleation reaction happening? Are you aware that KMNO for oxidizing agent? Are you aware that phosphoric acid is a weak acid? We have to know all this. These are the things which are tested, not your memory skills. That's it. Let's go to next question, guys. Here, we have one more important question. A reaction, a very important reaction. Yeah. So, ammonia, bromine gives rise to nitrogen and ammonium bromide is salt. This is a salt. Now, as I told you, first, we need to compile the basic things what you know about the reactants. So, here you have ammonia. Please try to compile all the information about ammonia. Ammonia is a weak base as well as a reducing agent. This is the information you got to know. However, bromine, aqueous, is definitely an oxidizing agent and its aqueous is acidic. How do we know? Bromine plus water always gives HBr and HOBr. This is acidic. This is acidic and oxidizing agent, both. This is the information we got to know. Now look at the reactants. So ammonia and bromine. So the possibilities are both acid-base reaction is possible as well as nucleation reaction is possible. I'm talking about only possibility. Now let us explore how is this. So here, if you look at the products here, we have here -3 state and here we have 0 state. This is 0 state and here we have -1 state and of course this is still. This is -3. This is -3. So what's happening here? What's happening here? Now nitrogen -3 going to is still -3 and nitrogen -3 here is from 0. So change in oxidation number, right? And bromine 0 here and -1. So what are the things now here? So bromine 0 to -1 it got reduced. However, nitrogen -3 to 0 it got oxidized. So here this part got oxidized from the reaction. I'm studying this and this part got reduced. So one thing short we can say here there is some kind of redox reaction involved. However, then what else? So if you look at the moles of nitrogen, here you have nitrogen atoms 8 and here you have 2 and here you have 6. Implies out of 8 nitrogen atoms, only 2 got oxidized and 6 is same. Oxidation number did not change. So this 2 got oxidized and the rest 6 are retaining the oxidation number -3. However, bromine we have 6. All 6 bromines are now got reduced to -1. Reduced to -1. So how do we understand this reaction? One thing is short that there is redox reaction involved. Now we have to explore along with redox reaction, is there any nucleation reaction or not? So let us understand this more clearly. Now, how do we understand this? Ammonium bromide and Br minus. If you look ammonium bromide, this is ammonium NH4 plus. Here it is very clear, ammonia is now changed to ammonium. Implies only by accepting proton. This is because nitrogen has a lone pair. This we know is a base, right? So definitely, this H plus with lone pair of electrons and giving rise to ammonia, this is base. Now, where is this H plus coming from? The source. Where is the source? Where is the source? The source must be somewhere here. How? I told you bromine aqueous. Bromine aqueous can have HBr and HOBr. So this is a source of H plus. This also is a source of H plus, both. Right. And here in HOBr, definitely this is +1 and this is +1. Br is +1. Now this is a source. So there is likely that since we have 6 ammoniums, implies 2 nitrogens got oxidized, whereas means 2 moles of ammonia got oxidized and 6 moles of ammonia are accepting 6 H plus ions. 6 H plus ions from this bromine. If you look at this, here each bromine unit will release 2 H plus ions. We have 3 bromine units. So these 3 bromine units should definitely release 6 H plus ions. This 6 H plus and 6 ammonia should definitely give you 6 moles of ammonium. That is how you have 6 moles of ammonium. And out of these 8 nitrogens, I said 2 nitrogen got oxidized. So if you take N minus 3 going to N0, 2 moles implies here it has lost 6 electrons. 6 electrons. This is nitrogen. 6 electrons. So ammonia is losing 6 electrons, 2 moles, therefore that is acting as reducing agent. And whereas, the 6 electrons should be taken up by bromines. Therefore, 0 to -1 is 1 electron each. So here we have compulsory 6 electrons accepted. Indirectly or through this, anything is fine. So now it is very clear. Here I showed you how 6 moles of ammonium is formed. And here we have 6 Br minus. 6 Br minus means this 3 moles of bromine is accepting 6 moles of electrons. Therefore, it is acting as oxidizing agent, and here 2 moles are acting as reducing agent. So therefore, here part of this reaction is redox, part of this reaction is also nucleation reaction. So you can simply ask a question, given this question, is it a nucleation reaction, is it a redox reaction, or both or none? So obviously, looking at the products, it is very clear that it is both. This reaction involves both redox as well as nucleation reaction. So this is the case. Now tell me, where is this? I've used very complex concepts. Where is that you need to memorize it? I'm simply talking about redox reactions, simply talking about nucleation reactions, which you have been learning from school, high school. That's it, dear. One more important, interesting reaction. Look at this. Here, how do you understand this? How do you understand this reaction? Nitrogen trioxide and a perchloric acid. Perchloric acid, is strong acid. Here you have a salt formed. Very important reaction. Alright, and here we know this is an anhydride. We learned in the last class also, nitrogen trioxide is anhydride, means in aqueous phase it gives nitrous acid, HNO2. But what you guys have to know is HNO2 is unstable in aqueous medium because of thermodynamic reasons. Unstable, this simply has to give NO2 water, sorry. Unstable. Usually, I'm not balancing here. Usually, this is the common product formed. N2O3 with nitrous acid gives you, water gives you nitrous acid, right? Now, question is, this is unstable. But however, this is also not very strong acid, weak acid. Now, if you look at the structure of nitrous acid, how does it look? NOH. And simply you have double bond O, HNO2, nitrous acid. Now I told you this is a strong acid, and of course this is a weak acid. As per the discussion, definitely perchloric acid being a stronger acid, it's simply here this perchloric acid ClO4 plus H plus, and this H plus has to attack OH minus, OH there, and obviously this forms water because this has to be broken, and plus NO plus, nitrosonium ion. So therefore all we have is now ClO4 with NO plus gives you a simply salt. So here again, a strong acid is protonating the weak acid, and thereby it is forcing it to act as acid, and that is how NO plus is generated, and ultimately you have a salt. A salt. So 2 nitrogens, obviously this is the case. 2 moles. That's it. Yeah, one more. It is also an important reaction. See, potassium ferrocyanide, this is potassium ferricyanide. So how to distinguish between these two in terms of oxidation number? Iron is in +2, iron is in +3. So usually oxidation numbers of iron will be 0, +2 ferrous and +3 ferrous. The basic thing you got to know. And there is no chance of reducing any ferrous or ferric to iron. This to this, this to this is not possible in test tube. These are not possible in test tube reactions. It is only in the blast furnace. Blast furnace. Yeah, how do we understand this now? Look that. Again, we got to understand what is the nature of these reactants. What is the nature of the reactants? Ozone, as you know, ozone is let me clear the board. Now, what is that you know regarding ozone? Ozone is very strong oxidizing agent. It is something around second or third in the position wise, ozone. So always ozone accepts 2 moles of electrons per mole and gives O2 plus oxide. This is the norm. This is how ozone reacts. One of the atom of oxygen picks up 2 electrons here and becomes oxide. So it is a strong oxidizing agent. This is the information you got to know. Wherever you use ozone, always it acts as strong oxidizing agent invariably. This is the point. Then here we have ferrous. Now ferrous, as I told you, we have iron in 0, ferrous and ferric. This is zero oxidation state. Now, if ferrous can go to ferric or ferric can go to ferrous, but these two going to zero is only in blast furnace. Otherwise, in a simple test tube, you can't keep on generating iron, right? Yeah. So this is the aspect you got to know. Now, where are we now? This being oxidizing agent, definitely, this is ferrous Fe plus 2. So ozone should oxidize plus 2 to plus 3. As simple as that. Now, it is taking up 2 moles of electrons per mole, and definitely here plus 2 to plus 3 is 1. So here we need 2 moles of electrons. So 2 ferrous should definitely lose 2 moles and give you 2 ferric in general. That's it. Now where is this KOH coming from? Here we are taking 8K plus, and definitely one possibility is only ferrous to ferric is only possibility. How many here we have here? Here. So here you have 2 ferrous. So definitely all 2 ferrous should go to 2 ferric. So that's how we explain 2 ferric here. Now how do we explain here? We have 8 potassiums, and here we have only 6 potassiums, and here you have 2 potassiums. Where is this KOH coming from? If you look at the same reaction, now ozone is accepting 2 moles of electrons to give you O2 plus oxide, and this is the source of O2. Now we don't see this oxide. No, we don't see this oxide. Oxide is strong base. What it does? It immediately reacts with water, picks up proton O, and therefore gives you 2 OH minus. OH minus. Therefore, that is how KOH is formed. So 2 OH minus need 2 K plus. Therefore, this 2 K plus, and rest of 6 are left here, and definitely ferricyanide needs only 3 potassiums per mole, and all the 6 are utilized here. Sorry. Again, guys, we have used, the key point we covered is ozone is one of the strongest oxidizing agents. It always accepts 2 moles of electrons, as I showed you here, and it generates oxide. In aqueous phase, this oxide is strong base and therefore generates OH minus. It makes the solution basic, therefore this is basic. And here, ferrous, this compound is acting as now reducing agent, and therefore it is getting oxidized to ferric. That's how we explain this. And mind you, potassium ferricyanide, potassium ferrocyanide, ozone, these are very important compounds we have in the syllabus. Yeah, let us understand one more reactions here. These are 2 reactions. How do we explain these products now? Look at this. Again, as I told you, what is that you know about sodium peroxide? So you should now compile the information about sodium peroxide. So this sodium peroxide in aqueous medium, this gives you sodium hydroxide basic plus H2O2. So this is alkaline. However, this is both oxidizing and reducing. This is the information we are supposed to know. However, carbon monoxide, this is a strong reducing agent. This with water doesn't form. I mean to say, carbon monoxide is not anhydride of carbonic acid. An anhydride should give rise to its oxy acid. H2CO2 is not an oxy acid here. CO doesn't give you H2CO2. If you look at CO, you dissolve in CO in water, its solution is neutral. If it were to form its anhydride, like its oxyacid, the solution has to become acidic, but the solution is not acidic. Therefore, there is no anhydride for CO. There is no anhydride for CO. The key point to be remembered. Therefore, coming to CO, it is strong oxidizing agent and it is always neutral. Neutral information. That's it. So definitely, what is that you're supposed to get here now? Yeah. This is what you're going to get. As simple as that now. So this sodium peroxide with water should give you sodium hydroxide plus H2O2, and carbon monoxide is strong reducing agent. Therefore, this is forced to act as oxidizing agent, and carbon is in +2 state. The stable state of carbon is +4. It must be +4. So H2O2 has to oxidize carbon monoxide to carbon dioxide, and it will definitely get reduced to water. Since this is acidic, and here we have basic, and these two in excess should definitely give you sodium carbonate. That's how here you have sodium carbonate and carbon dioxide. That's it. Then how to explain this sodium peroxide with ozone? Now, again same thing. This sodium peroxide is sodium hydroxide plus H2O2. However, this H2O2 is both oxidizing and reducing. We know this. I'll just need some board. So here, naturally, here you have what? H2O2. So the reaction boils down to ozone with H2O2. This being a strong oxidizing and this is a reducing. So definitely ozone, here it is -1 state. Ozone has to oxidize H2O2 to oxygen, and O2 is formed definitely. So ozone, as I told you earlier, picks up 2 electrons, gives you O2 plus oxide. O2 plus oxide, right? And this oxide with water gives OH minus. And here, these 2 electrons are taken up from H2O2. So H2O2 is acting as reducing agent and it has to get oxidized. So what is the oxidized product of H2O2? It is again O2. So -1 to 0. The reason you have O2 here and this sodium hydroxide. The source of this O2 is ozone as well as the peroxide. This is how when you apply concepts, when you apply the basic concepts what you learn to reactions, and definitely most of the reactions will be highly interesting, guys. And again, as you have seen, these are very simple things we are discussing, Same steps, same here, same. You can apply same concept here. Yes. Finally, how do we understand this reaction POCl3 and PCl5? Yeah. Again, anhydride with water gives H3PO4. We have 4 moles of this. So this 4 moles, P double bond O, OH, OH and OH. These are 4 moles. Here we have 6 moles of PCl5. PCl5 is this. As we learnt in the group 15 or in the chemical bonding, we know this. These are the equatorial bonds These are the axial bonds, which are usually weak, and these are strong. So what are the possibility? How to explain POCl3? POOCl3, and that to 10 moles. Where are 10 moles here now? Here we have 6 phosphorus and 4 phosphorus, 10 phosphorus. So how is that possible now? Now, one possibility is here, these two chlorides can be substituted by OH minus. OH, 2OH. If suppose I am taking 2OH minus is a reacting, substituting, all you will have is PCl, Cl, OH, OH. Likewise. So we have 2 chlorides can be replaced like this and 2 OH minus. Now where is the source of OH minus? Likewise, we have 6 PCl5, means in the 6 PCl5, each mole has 2 unstable chlorides. So obviously you have 12 chlorides which can be substituted. If you have 12 chlorides which have been substituted, then obviously what is the source of 12 OH minus? The 12 OH minus has to come from P4O10. Each one is having 3 OH minus. Definitely we will be needing 12 means 4 moles of phosphoric acid, which we already have. So this 4 moles of phosphoric acid will release 12 OH minus. We'll substitute this 12 chlorides. 12 chlorides. So obviously how many we are going to have now? Definitely now each of this will lose 1 mole of water, something like this, and this gives you P double bond O, Cl, Cl and Cl. That is POCl, POCl3. So each one should have. Now the question is, I showed you PCl5 is converting to POCl3. Similarly, the chlorides which are released from here are going to attack. And each phosphoric acid PO here, again this also will convert to on same lines POCl3. So from this we get 4, from this we get 6. So overall 10 POCl3, guys. That is a simple mechanism by which we can understand 10 moles of phosphorus oxytrichloride is found, right? So that's it. If you need to score well, if you are serious about scoring, right, though inorganic is boring, it doesn't interest you, right, definitely you need to find one or the other way, other mode, other logic, other application of concepts and make it interesting, because that is how you are going to stand out and you are going to have the edge over others. So nothing is boring here. We need this, we got to do this. So how do we do that? That makes a huge difference. So our methodology is, now let us apply some concept, let us apply some logic, let us apply some mechanism and then see whether can we make it interesting or not. And definitely one thing I can, the disclaimer here is, what are the mechanisms we are showing here? Most of these mechanisms are applied by common sense and logic. There is no proof. Our attempt is only to make the reactions interesting and logical by giving some reasons. That's it. So there is a disclaimer. We are not going to, we are not accountable for the mechanisms. It's only to make the things simpler, make interesting and to overcome the phobia among the children. That's it. Thank you.